Now let's see some graph and problems which will describe average speed and instant speed. Like this. In this curve, how we will describe the motion? You can see, if we draw the tangent here, this will be like this. If we draw the tangent here, it will be like this. Suppose this angle is phi 1, this angle is phi 2. So what we are observing? Phi 2 is greater than phi 1. Since phi 2 greater than phi 1, therefore tan phi 2 will be greater than tan phi 1. Since phi 2 greater than phi 1, so tan phi 2 will also be greater than tan phi 1. Therefore V2 is more than V1. So this curve indicates increasing speed curve. This is increasing speed curve. If we look at this curve, we will find, if we draw the tangent at this point and this point, we will find like this. This angle is suppose phi 1 and this angle is suppose phi 2. So what we are observing here, since phi 2 is less than phi 1, therefore tan phi 2 is less than tan phi 1, therefore V2 is less than V1. So this curve indicates decreasing speed curve. Let's see one more curve. This is distance time curve, like this. Here what we are observing? We are observing that in same time interval distance covered by the body is also same. So what we are observing here, if we draw the tangent or chord, it will be same. So here theta and phi at every point or every time interval will be same. In this curve theta and phi is same. So average speed is equal to instant speed. So this curve indicates uniform speed curve. Let's see one more curve. Suppose this is speed time curve. This indicates uniform speed. Let's see one more curve. If this is distance time curve, not displacement time curve, and curve is drawn like this, then this curve is not possible because distance is getting decreased with increase of time. So this curve is not possible. Now we will see some more examples which will describe speed and average speed and their calculations. We have already seen that area under speed time curve gives us distance covered. Let's see one example. Suppose this is a speed time curve of a moving object. Since speed can never be negative, this is speed time curve. Speed is calculated in meter per second and time is calculated in second. Suppose this is a curve for a moving object. Suppose this is 10 seconds, this is 20 seconds and this is 30 seconds. This is suppose 10. If we have to find distance covered by a body in 30 seconds or 20 seconds or 10 seconds, whichever is the case, if we have to find distance covered by a body in 30 seconds, 20 seconds or 10 seconds, whichever is the case, what we have to do? We have to simply calculate the area under VT curve bounded by time axis in given time interval. First we will find distance covered by body in 30 seconds. So what is distance covered by body in 30 seconds? Simply calculate the area between VT curve bounded by time axis like this. This is triangle. Area of this triangle is what? Half base into height. So half 10 into 10 is this area. What is area of this rectangle? This is 10 into 10. So this is 100. Once again, what is area of this triangle? Half into 10 into 10. So what is distance covered? Distance covered by a body in 30 seconds equal to this area A1 plus this area A2 plus this area A3. A1 plus A2 plus A3. This is equal to half into 10 into 10 plus 10 into 10 because this is 20 minus 10, that is 10, plus half into 10 into 10. So this is 50 plus 100 plus 50. So distance covered by a body in 30 seconds is what? This is 200 meters. So this is the way we can calculate the distance covered by body when speed time graph is given in the problem. Let's see one more example. How we will find average speed and instant speed. Suppose this is a distance time curve. We know that slope of chord of distance time curve in given time interval gives us average speed. And what is instant speed? Simply find the slope of tangent of distance time curve at a given instant. That will give you instant speed. Suppose a body moves like this. We should not be worried about the zigzag path because distance should not decrease, distance has to increase. So graph is okay. Suppose here, this time is 10 seconds, this time is 20 seconds, this time is 30 seconds, and this time is 40 seconds. Suppose here distance covered by a body is 10 meter up to here, distance covered by a body is 20 meter up to here, distance covered by a body is 20 meter, and here distance covered by a body is 40 meter. Don't worry about the scale of the graph. We are here randomly plotting the graph. Suppose if you have to find the average speed of the body between 0 second to 40 second, average speed of the body in 40 second. What is average speed of the body in 40 second? In this graph, average speed is equal to total distance covered divided by total time taken. So average speed in 40 second is what? Distance covered by the body in 40 second is 40 meter and time interval is 40. So average speed in 40 second equal to 40 upon 40. So average speed here is 1 meter per second. In the time interval t equal to 0 to t equal to 40. Suppose in this graph we have to find average speed between 10 second and 20 second. Average speed between 10 second and 20 second is 0 because between 10 second and 20 second body is at rest, body is not moving. Suppose if we have to find average speed between 20 second and 30 second. So what is average speed between 20 second and 30 second? Average speed between 20 second and 30 second is, here distance is 10, here distance is 20. So distance covered by a body between 20 second and 30 second is 20 minus 10. And time interval is 10. So average speed of the body between 20 second and 30 second is what? 10 upon 10, that is 1 meter per second. Here average speed between 0 second and 10 second is what? This is 10, this is 10. So average speed between t equal to 0 and t equal to 10 second is once again 1. So in this way we can calculate the average speed.